Alright, so now let's talk about the intermediate value theorem. First, I'll provide what the actual theorem is, and then I'll show you an example. Okay? So it starts off like this. If some function f is continuous on the closed interval AB, where A and B are just some x value, and if f of A does not equal f of B, and k is any number between f of A and f of B, then there is at least one number, C, just some number, in the interval AB, such that f of C equals k. Right? So that's great and all, but this is just a bunch of words, and they're really just kind of meaningless if you don't understand them. So let's draw a picture. Let's say here's our A, here's our B. Let's say our f of A is up here somewhere, and our f of B is here, and then let's say k is here. And since C has to be in between A and B, let's say it's here somewhere, and you'll notice that k is in between f of A and f of B, right? So let's say our function is something like wee, okay? So here we can see that our function is continuous because I drew it in one line. I didn't have to pick up my pen, and you can see that our C and our K correspond. The intermediate value theorem is useful if you need to figure out if something is in between them, right? So now I have sort of like a real-life example problem. Well, it's not much of a problem, it's just an example of the intermediate value theorem. So let's say we're on this grid, right? And we have Barbie over here. She's at her house, just having some party maybe at her house. Okay? And she invites Ken over, right? And Ken has to take this path to her house, but the only problem is that this path passes through where Stacy lives, right? So, by the intermediate value theorem, you can guarantee that Ken is going to pass Stacy on his way to Barbie's house. That's all for the intermediate value theorem. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!